it will become more complex. And if your table will become more complex, to retrieve the data, to update the data, it will be a problem. For example, let's assume that you have a university table. Let's assume that instead of making the database, you have made one table, right? Because database is a combination of many tables, right? And let's assume that you have made only one table out of universities. So in the university table, how many attribute you have? So you have, let's say, the all the attribute related to the student, all the attribute related to the faculty, all the attribute related to the let's say the admin, all the attribute related to the library. And you assume, if you'll assume this particular complex table, the table will become very big, right? As well as you have to put some extra data on this particular big table. So the database designer have come up with the idea like to minimize the size of a relation or size of a table. So how we can minimize the size of the table? The simple uh, solution is to decompose. Decompose means one table will be divided into many tables. Or if we have one table, can we divide that particular one table into n number of tables? So that is the objective of decomposition. Okay. And definitely if we have the big tables, we will get some anomalies. That is called anomalies. Anomalies means some problems. So the anomalies has been divided into three category. The first anomaly is insertion anomaly, second is the deletion anomaly, and the third one is the updation anomaly. Okay. So about those anomalies we'll see into some later classes, where we'll learn about the normalization process. On that we'll see the normalization. On that we'll see the anomalies. So anomalies are the problem, or the you can see anomalies are the what we can see the it is making our database less interactive, or you can see thus anomalies make our database clumsy. It will put in our database many inconsistencies. Okay. So to remove those inconsistencies, to remove those anomalies, we have the concept of decomposition. So let's talk about decomposition. So if we have a big table, and that particular big table is, let's say, R, and this particular big table is divided into R1, R2, R3 up to Rn, that particular procedure is called decomposition. So there is a rule of the decomposition. What is the rule? Rule is this: if you have R as a big table or big relation, you are dividing the relation into R1, R2, R3 up to Rn. If you'll make a union of all the relation that you have divided or decomposed, you will get R again. Getting it? What I'm saying? If you have a big table R, and R is divided into, let's say, R1, R2, and R3 table, means we have decomposed the big table into three small tables. But if you'll make a union of these three, union operation of these three, so you should get R. You should get R. Then only your decomposition is successful. Okay, then only your decomposition is successful. This is example where we have R, a relation. X, Y, and Z are the three attribute of the relation. In one relation, we have after the decomposition, in one relation we'll get XZ, and another relation will get YZ. And if we'll make a union of these two, we should get R again with X, Y, and Z. That is a concept of decomposition. Okay. So if you'll perform the union operation of R1, union R2, you should get R again. If you're not getting it, it means that whatever procedure you have used for the decomposition is not correct. Is not correct. What is the goal of the decomposition? The goal of the decomposition is to eliminate the redundancy by decomposing a relation into several relations on a higher normal form. So once we'll see the concept of normal form, you will get to know that the procedure of decomposition will help to eliminate the redundancy. Redundancy means duplicate. Duplicate data from the big table could be removed. And if big table is taking, let's say, 5 GB of space, and in that we have some duplicate data, maybe if we'll decompose the big table into a small table, let's say R1, R2, R3, so you will find that the size is drastically reduced. So that is because the redundancy or the duplicacy in the big table will be removed when we decompose that big table into small tables. That is the goal of the decomposition, and that is why we are doing decomposition. It is important to check that the decomposition does not lead to bad design, right? So we have to look for the decomposition procedure. That procedure should be a very good procedure to enhance the database design by eliminating the redundant data, by reducing the anomalies, by reducing the inconsistency in the big table. So that is the goal of the decomposition. Now, what are the problem that we'll get in the decomposition? Given instances of the decomposed relations, we may not be able to reconstruct the corresponding instance of the original relation information loss. Now, what it is saying that what are the problem that we'll get? The problem we'll get is in decomposition, we'll get the problem of information loss. What is the meaning of information loss? So to understand that, we'll see one example. Let's say this is the example. Okay. Now in this example, we have a relation R in which we have this particular table is about the camera, in which we have the model number of the camera, the price of the camera, and the category of the camera. Okay. If we'll see this table, in this we have model name, price, and category, three attributes. We have three data inside it. Model name is there, A11. Price is there, let's say $100. Category or the company is Canon. Now the model is S20, the price is 200, and the category is Nikon. Again, the model is A70, the price is 150, and the category is Canon. So we have these three data inside a relation. Now what we have done is we have decomposed the table. And in one table, we have model name and category. Another table, we have price and category. So in the model number category, so we have A11 Canon, S20 Nikon, A70 Canon, that we have written in one table. Another table we have price and category. So we have 100 Canon, 200 Nikon, and 150 Canon. Now it looks good, but the thing is that while again finding out the relation R, it will be a problem. How? If we'll see this, if we'll make a union of R1 and R2, so what will happen is we'll get some extra attribute. These are the extra attribute that we'll get. We'll get A11 150 Canon. Do we have A11 150 Canon? No, we have only one instance of A11. Here we are getting two instances of A11, in which this instance is extra, or we are not getting, we are getting the false information here or false data here. Now again, A70 100 Canon, which is not there. A70 100 Canon is not there. Here we have A70 150 Canon, but we are getting A70 100 Canon, and this particular is again a duplicate extra information we are getting, which is a wrong information that we are getting. We should get this, right? Now what are the problem? The problem is with the decomposition, how we decompose the relation. We should decompose the relation based on the key, based on the key attribute. Now here, what should be the key attribute? If we'll find out the functional dependency, you will get it that what are the relation between these attribute in terms of roll number and name, right? So you'll find out that model name determine price and category, because category could not determine the model name. Yes, it is a name, right? So it will be a roll number in that way. So model number will be your key attribute. So based on the model number, we have to distribute. If we'll distribute based on the model number, definitely we'll get this particular R. So how we'll do that? Let me tell you how we can do that and why we are getting the extra attribute here. Why we are getting this? So in this, if you'll see this R1 and R2, and if you want to make a union of R1 and R2, how you can do that? You can make a union of R1 and R2 by joining these two tables. How will join these two tables? We will join these two tables with the help of the common attribute. What are the common attribute we have? We have category is the common attribute in these two, right? Category is the common attribute in these two. So for that, what we do is we make a join of it. So here we have model name, price, and category. Let's go for the first one. A11 Canon. Can we join? Yes, we can join with this, because Canon and Canon are the same, right? So with the help of this, we can join it. So A11 100 Canon, A11 100 Canon, right? So this will be your first data after joining. A11 Canon, can we join with this? No, because Canon here we have and Nikon here we have, we cannot join. Can we join with the third one? Yes, we can join it. A11 Canon, here also we have Canon. So here we'll get A11 Canon will come, and this is the 150. Now let's go for the second one. S20 Nikon. Can we join with this? No. Can we join with this? Yes. We can join with this. With the common attribute, we are joining it. Okay. So S20 200 Nikon. Now next is A70 Canon, we can join it with this Canon. So it will be A70. This will be 100. And here we have Canon. Again, Canon, yes, we have another instance of Canon here. We can join it. A70, 150 Canon. Now this is the table that we'll get after what? After joining these two tables, after making union of these two tables, right? Joining and union are the same here in this particular database category. Now it should be R. Is it R? No, it is not R. This is R, in which we have only 3 data. Here we are getting 5 data. What are the data? That is extra data that we are getting. This is the data that is extra data, and this is the data which is extra data, and which is making your decomposition wrong or lossy. That is called lossy join or lossy decomposition. Lossy decomposition. This is called lossy decomposition. Why we get lossy decomposition? Because whatever method we have applied for decomposition is wrong. What should be the base for making the decomposition? So we have some normalization form which is called normal form. That we'll see later part of this particular course. So with the help of normal form, we have to decompose it. Okay, we have to decompose it. Now this is a common sense that based on the primary key, we have to decompose it. Here, what is a key attribute? Key attribute is model name. Model name is just like your roll number. Okay, so based on that, we have to decompose it. So if we'll decompose based on that, so in R1 and R2, what we'll get? So in R1, we'll get attribute like model name and let's say price. And in second, we'll get model name and category. So based on model name, we have divided. And here in this particular decomposition, they have divided based on the category. Now, when we apply this particular rule, so we'll get 3 instance here, 3 instance here, just like this. Here also we have 3 instance, here also we have 3 instance. But when we get a union of R1, R2, will not get this extra attribute. Will not get this extra attribute. Okay. So can we see that how it will be divided? So let's do that. This is R1, this is R2 based on the model name. Model name. Here we have price. Again, model name. Here we have category. Let's see what is in this table and this table. Model name is A11. Price is 100. S20. Price is 200. A70. Price is 150. Here model name again A11. Category is Canon. S20. Category is Nikon. A70. Category is Canon again. Now after that, what we do is R1 will make a union of R2. So let's do that. We should get R. We should get R. Okay. So what is in the R? We have model number, we have price, and we have category. Okay. Let's do the same thing with the help of, because this is the common attribute, we have to take this A11, A11. We can join it. What will get? A11, 100, Canon. A11. Do we have any other A11? No. S20. Here we have S20. This is not S20. This is also not S20. We are getting S20, 200, Nikon. Based on the model number, we are making a join or making a union. A70. Do we have A70? Only one instance. This is going to join. So it will be A70, 150, Canon. You can see we are getting R again, R again. This is the lossless join. This is called lossless decomposition or lossless join. This is called lossless decomposition, right? R1 and R2. And this is called lossless join. And this is called lossy join. And this particular R1 and R2 are lossy decomposition. Getting it? So we are actually getting extra data here, but the concept is we are in the loss of information. Why we are loss of information? Because we are getting these extra data which is of no use or which is making the confusion in the database. So here, if somebody will come in my shop and they will ask for A11 model number, so I have two prices of A11, 100 and 150. It will make a confusion in my shop. As well as if somebody will ask me the model number A70, I have two category of A70 of $100 and $150, but the actual price is $150. If I'll sell it with $100, I may be in a loss. So this extra information, while a decomposition in a lossy way will making my business lossy, right? As well as I am getting these data which is of no use. That concept is called lossy decomposition, and we do not want lossy decomposition while decomposing the big table into small tables. That is the whole concept related to the decomposition. About that, we'll see some more concept in the later classes.